I'm glad to see this many people braving the cold to come listen to me. This will be fun. I'll be telling you about some ideas we've had for doing something more than we usually do in playing with text for search engines or information access more generally. My first question is, I guess, how many here consider themselves to be linguists or half linguists? A handful, okay, because you might actually disagree with some of the things I'm saying, or hopefully not, but it's quite possible. And how many here work with the search technology as their main thing, just to sort of get a sense of it? Fine. Okay, we're there, and there are some probably who are neither, but you'll just have to sort of bear with us. So I was supposed to hold this talk a year ago, more or less, but things got a little bit confusing. There are two good reasons for that, one better than the other, and it's always worse to have two reasons than one, but the not as good reason was that I was very absent-minded because I thought that the world was different. Because I've visited Moscow several times, but the last time before this one was 25 years ago. And Moscow has changed, and I thought the world I expected it to have changed, and I thought the world had changed more, so I didn't know we needed a visa. So I had to turn back at the airport. That was sort of a disappointment, but I'm here again. I'm very thankful for Yandex being patient enough to give me a new chance of coming here. The better reason is coming up in a little bit here. So this is my name, and these slides I'm sure will be distributed through Yandex, but I will also put up them on my homepage, and usually it's easily findable by my name because not many people have that exact combination of names. Let's see. So this is me in few words. I've worked since about since I last was in Moscow with things to do with the computational analysis of language. And for most of that time, I worked with search engine or information access related things rather than translation or dialogue, but mostly processing large amounts of data. And that has informed some of the things I want to do. I've done most of this, again, at SIX, which is an institute in Stockholm. I'm also sort of associated with the University of Helsinki, and I have recently started a company together with some friends. That is the second good reason why I was sort of absent-minded a year ago, because I had a lot to think about right then. So this is about SIX. I'm sure you have similar institutes here. It's a non-profit, mostly industrially funded institute right outside Stockholm. We do all kinds of computer science related things. Some are dull but very useful, and some are very nifty and less useful, and my stuff sort of comes in between. The company I started is named Gavagai. It does large-scale analysis of text, as you might sort of, not a very surprising thing. We work on extracting actionable intelligence, is the phrase we use. Interesting stuff from very large data streams. We do it with a number of technological things we've come up with, which aren't in this talk, but what I will be talking about might be fed into Gavagai eventually. Let's see if this is woken up in the meanwhile. Yep. So the first question to ask is, why would one want to use computational methods for information access to begin with? I mean, what is the reason for employing computers in viewing it largely, say, digital libraries and databases? There are two main reasons to doing this. One reason is that sometimes there's just enormous amounts of data, and it's difficult to do it well if you're a human. Say that you have a very large database, it's difficult to, remember where all the files are, and it's easier to have a computer there to retrieve the stuff. This is a task that a human would do better than the computer. But since the scale of the task is huge, it helps having a computer there, because it will be able to do it numerous times without tiring, and it will be able to keep all those data sets in time. This is, let's call these simple tasks. This is not to be, less than gracious to my host here today, but to, These are, in essence, simple tasks. The challengers are scalability rather than anything else. I mean, of course, these two tasks flow together, but the other one is where the signal in the data is very weak. And these are tasks that are difficult for human language users as well. Tasks like, let's call these difficult tasks. These are tasks like authorship attribution, which is a task I've been sort of playing with, or stylistic analysis of text, where it's very difficult to get consistent answers from people as to what happens in the text. So if you give people a bunch of texts and have them sort them into piles by topic, they do it fairly well, usually better than computers do, unless the amount of data is large. If you ask people, has this person written this text or not? Has Solokhov written all the books that he's claimed to have written? Right? Then people can write enormous amounts of books, more books than Solokhov ever may have written about the fact or not, and still disagree. Right? And this is typical for difficult tasks. You might use a computer there to actually tease apart the feature space somehow, so that you can give these answers better using computational machinery. And I'm leaving this distinction now. I'll probably return to it later in the talk, but the idea is there are two reasons for using computers. And if all you want is scale, there are simple ways of doing stuff. But if you want to do more than the simplest tasks, then you might want to do something which at first doesn't seem worthwhile. Okay. So for the simple tasks, this is a claim. The sensible thing to do is to, just be very violent and break the text into its constituent parts and retain the most informative ones and throw out everything else, and then, in essence, build an index and then use that index instead of the texts. Right? This is what search engines do, right? It's again a simple task. There are lots of non-trivial challenges there to be able to do this well, but they're not linguistic tasks. They have rather less to do with the text itself. Now, of course, selecting the interesting bits, that is interesting still. That is still a difficult task. But in general, this is one way of proceeding if what you want to do is to, pile texts into piles, topical piles. So this is what I just said. So what's the next sensible thing to do if you want to do something more, if your task is more complex? You might try to organize the bits you find after you pound the text into, its constituent molecules. You might try to organize the bits into piles first, generalizing them, the bits themselves, not the texts, looking at the words or whatever is in the text. And you might try to see if the bits have relations to each other somehow, building more complex structures over the text. So that if you have a text, you might, relate the bits in the text to each other in some complex way. This is really a non-trivial task. And it results in stuff that's not always useful. So, okay. So this is one of the side claims, and this is where you who consider yourselves to be at least half linguists are allowed to disagree. Okay? So why is parsing, which is the obvious choice to go further once you decide, okay, I need more than just the bits that are left after I pound the text to small molecules. The next obvious thing is you look up your linguistics textbook and you find there's something called parsing. There's a technology there that will enable you to, find relations between bits in the text, and that seems very useful. Okay, so why is this impractical? There are several reasons for this. I'll go on about this. I'll return to these things in a bit, but the most important thing is that the parsing procedures are usually built for a specific type of text. And the type of text that linguists have had access to in any volume, besides the sentences they themselves have designed for their algorithm, they're usually very well edited. Linguists sit down and they invent a sentence and they say, okay, let's try to figure out how this sentence works. Or they encounter a sentence and they work on that sentence or a set of sentences. And then they test their stuff. If they test their stuff at all, they test their stuff on corpora, on various corpora of text. Now, the text that they have had, or we, I should say, since I have been doing this myself, have had recourse to have been newsprint, corpora of, books, novels, technical text, patents, say, a legal text, sometimes the Bible, and these are all very well edited, right? They've passed through numerous hands before they actually grace a page of a book, right? It's very seldom these texts have, been generated off the top of one's mind. Usually they've been, gone through and the commas have been changed a little bit and the spelling has been corrected, which means that when new text comes along, namely, say, the stuff that's been generated today in enormous volumes, it behaves rather differently. Typical parsers don't really handle blogs, for instance, or tweets, right? And this is not because the parsers are bad in themselves, but because they're designed for a different data set. They're designed for a completely different data set. And, there probably could be a parser eventually built for that. But the second reason is stronger. The categories a parser uses are typically unfounded in the data. Now, I don't know. This is actually a question I'd like to find out. How many what in English is called parts of speech have you been taught there is in Russian? Most of 10. Okay. I was taught there are 9 in Swedish. And both of those figures are completely arbitrary, right? Most of you will remember, some of you will have suppressed the memory, of having practice in schools assigning words to the categories of parts of speech. And you remember that was difficult, even for those of you who thought it was fun. I thought it was fun, and still I found adverbs were, it's the catch-all, the final else clause in some sense, and it's still difficult to know if something is an adverb or not. Because the categories are based partially on referential semantics, stuff that's real, including unicorns, and then stuff that you do, including shining, like the sun shining, and then, lots of other stuff that modifies the other things, and which is a very abstract, procedure to think about, especially when you're around 10 to 12, when you're supposed to do this in school. These categories are not typically the useful ones you need to do well in an information access task. If you have really a very competent or let's say a very hard-working set of linguists, you will be able to assign a category label to every word in text. And typically most practical computational linguistics applications have use in practice something like 60 categories, because it's not very useful to assign something like 10 to words. Now, does anyone here work with a parser for Russian? How many categories do you use for your 12, 15. And how did you find those categories? They're standard categories, and then you've... Okay, someone else invented them, right? And that person who invented them, I'm sure wasn't thinking about parsers when he or she invented them. Right, you fit something from the literature to your task, right? But my point here is that the categories that we typically use, and I have done this myself, right? So I'm allowed to say this. Those of you who are not at least half linguists are not allowed to criticize linguists in this way. But the categories are unfounded because they're taken as true. And there are people out there who try to invent or to, infer categories from the word's behavior, but that usually, that's the sort of thing I'm trying to do today. Now, the other thing I have problem with parsers is that the edges in the graph, whether you're building a tree or a dependency graph or whatever, they're not usually based on anything that's designed to be useful. The typical target of a parser is to cover the entire sentence, right? Every word should be at the end of an edge, if possible. The target notion is coverage. And that's not necessarily... this might be true for very well-edited text, but for, text where people push in stuff afterwards, seeing, I saw this thing over there and, the car, white, that sort of thing. It's very difficult to figure out a way of achieving a maximum coverage parse for a sentence where you actually incrementally are adding stuff to it as you go. just as an example. So dependence, I have trouble with the categories and the dependencies of parsers. So this is where I started. Okay. So the question is, what's in the signal? This is an example sentence we played with because it was in a task. I will come back to the experiment in a little bit. So it's just something picked out of newsprint, right? Some sort of news text, well edited. This is, this is excellent bookish and well designed English. So what's in this sentence? Now, as a search engine professional, the answer is words, right? And linguists would say that there's something more. But like I just said, the linguistic answer doesn't really help much in the way of practical applications, because there's something that it's said that the recently deceased Fred Jelinek, I'm not sure it was him, said about speech processing. He said that every time I fire a linguist, the performance goes up. And I'm not sure he claims he didn't say this, and but it's a sort of a nice catchphrase, right? The idea being that if you try to process too much, you don't actually add efficiency. You definitely don't add efficiency. You lose efficiency, and you don't add much in the way of performance because you waste your time on the final cases. Right. So what could we do instead? So this is an argument to those of you who say, okay, what's in this? Let's go back here. What's in this signal in the blue sense? It's just a bag of words, because this is the way search engines view things. Okay. What's in the words? Is there just words or a pattern? Okay, this is something someone told me, more or less, like this. The words are in the clause. There's no pattern there. There's just words. The pattern is only incidental to the words, right? So, it is cold in Moscow today, right? It has a number of words. Those are primary, and the pattern is just, something that they're organized. It's just their organization, and it wouldn't be there if the words wouldn't be there. One person not, agreeing to this statement. Are there more? I don't agree to this statement, so don't nod if you want to be my friend, because the point is here that, okay, and I found a very nice quote. So patterns don't exist when not in use. This is, the idea. The patterns are not there, but the words are there. This is something Skinner said. Most of you will have heard of Skinner, the behaviorist psychologist. He was also a very bad linguist. He wrote a really bad book on verbal behavior, but it had a nice quote, which I like to put up here. To ask where a verbal operand, that's a word, is when a response is not in the course of being emitted, meaning to ask where a word is when it's not being said, is like asking where the knee jerk is when someone is tapping on your knee with a hammer. Right? So there's no words unless they're being used. And I sort of agree with this. There are no more words than patterns. They have the same ontological status, to use a term. So the claim of myself and my colleagues are now that the patterns are part of the signal. They're not secondary to the words. They're just as much in the signal as the words are. And this is, a contentious statement. This is something people will be able to argue about without agreeing ever. But the point here being that no, it's not the case that a clause, like the blue one you just saw, is composed of a number of words, and then you can deduce some organization. And my claim is that there's a pattern, and there are words, and they're on the same level. The reason we see the words is, A, we've been taught to look for the words and not for the pattern. B, our writing system is such that we represent the words, and the pattern is incidental to the words in terms of our writing system. Right? But be that as it may, this is the starting point of where we started to play with stuff. Now we found a very nice theory called radical construction, or construction grammar, and specifically the radical version of it, it's self-styled radical, which has 3 starting points. I'll go through them as well. This is linguistic theory for those of you. So the first, for those of you who are interested in this, you can look up William Croft's work if you're interested in this in any greater detail. So one of the points of radical construction grammar is that there's what he calls a syntax, or what is called in the field a syntax-lexicon continuum. There's no difference between lexicon and syntax. There are, just like we just reasoned previously, patterns such as syntactic patterns, like it is cold in Moscow today being a predicative clause with a copula and so forth, and idioms such as let's say, Can't think of any idioms at present, but there are, standard conventionalized collocations. Morphological behavior, the atomic categories used, and the lexical items, they're all on the same level. We experience them as they're being uttered or written, and we experience them as they're being heard or read. And we don't experience the one more centrally than others. If someone is saying the sun is shining, we hear something about the sun and something about shining and something happening. And all those three hearings are on the same level, right? This is my claim. This is sort of the linguistic claim. We can actually go through this rather quickly because it's not important, but the point of construction grammar being you don't first build a parse tree and then you analyze the parse tree to find if there's a semantic analysis. It's all in the same model. And it's sort of a structuralist account. There are no language universals that are realized in terms of syntax. There's just patterns. Everything that is patterns. This suits those of us who like nice, clean, and very simple models, and it suits us for practical purposes, and you'll see soon why. Okay, so this was a bit theoretical, but we have a practical experiment coming up, so bear with me here. So this is just saying the same thing again. So to study patterns, we don't need to sort of first find the patterns and then look at the words and then hang the words onto the pattern, which is what your business is in the back of the room. We look at them separately and together, in the sense that we look at them in parallel. This is what our experiments go for. So, patterns have been used in linguistics, in computational linguistics, or rather in language engineering, for some while, in a way rather like this. The whole information extraction project, or task, is sort of a pattern-based thing. You look for you sort of describe a pattern, saying, okay, this is a pattern. An airplane accident is a pattern, and it's expressed in any of these ways. When someone tells you something about airplane accidents, they will say things about, there was an accident and an airplane, fell down from the air in an inappropriate way and people got hurt and it happened somewhere. And this pattern can be described in a fairly abstract way or a fairly concrete way. This is what information extraction is about. And generalizing the thought about this is what we're sort of doing. So, okay. So the example task we played with was attitude identification, which is also known as sentiment analysis or opinion identification or attitudinal analysis. There are numerous words for closely related tasks. So this is what we did. We used let's skip this. We used news text. So this is a prototypical attitudinal expression. Okay, there is someone who expresses an attitude towards an object. Okay, I like sauerkraut. Okay, there's someone there, there's a sentiment term, and then there's a topic. Kissing is nice. It's implicit who likes kissing. Okay, so we look at some phrases from text. The first one is the one you saw before the blue sentence. And it's sometimes very difficult to even decide if there is an attitude in the sentence, right? It's very difficult to decide if these... Okay, some of these at the end, this is very clearly an attitudinal one. The designers, this is a... I think they make men's clothes, do not like random play, which is something they don't like, which I'm not quite sure about what it is, but they don't like it. Okay, so here's someone, here's a liking thing, and here's something they don't like. Here's a sauerkraut thing again. Implicit, but someone expresses a clear, relative opinion about stuff. This is something I agree with. A certain type of boats, they have this, and they handle well in choppy sea. This is something that is true for these boats. And so, but, okay, so these first ones, okay, so Mr. Cohen, beginning an 8-day European tour, including, said he expected further international action soon. Is that an attitude? Is that an opinion or not? Okay. The first one, or the second one there, President Assad has said that it's a pressing need for the region, considering a peace a strategic option. One of these is considered, some of these are taken from an experiment that was done at NTCIR, one of these standard experiments, Trek-style experiments. I'll get back to the details in a bit. And the second one, I believe, is considered attitudinal, the third one, not. They're quite similar, but Okay? So, what we claim here is this attitude is not as simply just lexical. It's not just the case where I like X and some synonyms for like. It's very difficult sometimes to, he has the best result, we can't fail him, versus this is the coffee, we can't fail with it. How do you, just from word statistics, you can't look at the words and find, okay, there's fail in it and best in it, it must be attitudinal. It's not quite clear where the locus of the attitude is in the sentence. So we claim that there is a pattern in play here, or a set of patterns we can use for experimentation. So to study patterns, our claim is we don't need to encode explicit linkage to words. We look for patterns and we look for words, and then we treat them the same way. Okay? So we take a lot of sentences, and from these sentences we pick out all the content words, the words that are words like coffee and powerboats and peace in the region, and then we pick out form words, which are the structural terms, stuff that usually is in a stop list, and then we have a certain small hand-coded set of patterns, because this is our first experiment, right? And this is using categories that I just earlier treated very badly in this course, but we started here because this is what we had. So here, content words using categories we don't like, function words also by criteria we don't quite like, and then some sentence structure predicates taken from our intuitions as linguists, like highly transitive sentences, some object clause tense shifts and stuff, and numbers of various dependents. This is all in a paper you may want to read after I've talked about it. So okay, so this is an example. This is again the sentence you first encountered. So here's a bunch of content words. Okay, hang on. There, yeah. A bunch of content words, a bunch of, closed class words, and here is a bunch of observed patterns. Now, these patterns are observed in this text in the sense that looking at this sentence, so okay, here's one of those patterns. Okay, for instance, one that I know is interesting is tense shift. Okay, there are two clauses in this sentence. It's a long sentence. It is this, I think, that commentators mean. There's actually three clauses when they say that the world changed. Four finite verbs. So okay, they say that the world changed. Okay. There's a tense shift, so there's a difference between the surrounding clause and the subclause. That's an interesting observation we will find in a little bit. So we collected a number of these observations and looked for them in every sentence. So all we have now, we represent this sentence with these features. Okay? We don't have any parse trees. We don't have any dependencies between words. We've thrown out all that information. All we have is that we noted, okay, we found a time adverbial. We found another, which is September 11. We found an adverbial of manner, glibly. There's an object clause, there's a predicate clause, there's a transitive, intransitive clause, and there's a transitive clause, and there's a mix of both. So we note all these things, and we just, keep these in mind. And then we let's see, here's an example of the tense shift I just said. Noam Chomsky said that what makes language unique is, and Halliday believed that grammar is natural. These are tense shifts, right? Okay, there's a past verb and there's a present verb. This is an observation that actually holds, we found, for very many clauses of this type. So this is sort of preliminaries. Now we ran all this through a huge number of sentences, and we found here that had been manually, not by ourselves, by other people, categorized as being negative, positive, neutral, or non-attitudinal. These are attitude, but either difficult or impossible to determine whether they were positive or negative, but they were attitudinal in some way. Okay, so to the left you'll find stuff that is attitudinal. To the right you'll find stuff that is not. This is using a correspondence analysis technique, which is a standard visualization technique for exploratory data analysis. It's sort of fun. You can project the features and the categories in the same 2D space in this way. It's sort of a principal component analysis with a visualization widget. I highly recommend it. It's fun to use. Okay, so here what we found is that some of these features really strongly indicate that there is something going on. Okay, so then we did this for real. We ran this for a set of 4 sets of standard tests, because we found 4 sets out there that were easily accessible, that people had tagged for being positive or negative. And then we used the technique we like to use. We put them in a word space, a semantic space based on distribution. I will not talk about this technique, but I'm sure many of you have heard of word spaces, semantic spaces. So the idea is we use distributional statistics so that words, or in this case features that occur together, end up in the same neighborhood. So we can ask cat and dog will end up similarly, and eat and drink will end up similarly, whereas cat and eat, hopefully not, right? We extract feature vectors from word space, and we run it through a categorization standard tool, and we test with the standard 5-fold cross-validation technique. So we did this fairly seriously, and we had, this number of sentences. So we had 1,000 or so sentences in each category. In the last category, last test set, we had about 10,000 in these, about 5,000. This is a smaller set of 250 ones. And then we also trained the system on a very large amount of background data. So in essence, it had read a year or so of newsprint as well, besides this text. So running this text, and this is all in a paper as well, last year's ECIR. Running this, we found that using the constructional features helped the results. In some cases significantly, in some cases less significantly. It never hurt. It was never a bad idea to use them, really, but sometimes they didn't really help at all. In this case, the difference is non-significant, but it turns out it adds some noise. So these are 4 different test sets. So now, what we can say here is that, let's see, this is an apology for the last test set where it actually didn't help, is that there were news headlines rather than text. So they were very different. This is an example of why it's different. This is a very positive one. Discovered boys bring shock, joy. This is American newspaper headline syntax. And Iraq car bombings kill and wound, that's a very negative one. But it's very similar in structure and in content, because shock and joy are both, strongly attitudinal words, and sometimes it's difficult to say what's what here. But this is a very different data set, and here the precision was much lower. But the other ones, fairly good. So our finding is, to skip that, our finding was really that generally using constructional features helped. So it added some information to the purely word-based features. So it's better to use constructional features than to use just the bag of words. And this is without linking stuff to each other, without saying, okay, we now found that Jussi Karlgren likes sauerkraut, and sauerkraut is the object, and Jussi is doing the liking. We just found there's something about Jussi, there's something about sauerkraut, there's something about liking, and also it's a transitive sentence. Right. So putting all those things in the bag, so it's still a bag, there's no sequence, there's no structure there. Putting all those things in the bag, we found it improves results for this task. This task is then obviously more demanding than a search engine task. We weren't looking for sentences about sauerkraut or about liking or about Jussi. This was just this is a very specific task, and of course this processing was hard work. I mean, we ran the system fairly efficiently, but the hand coding of the thing that found the features took a while. This was still doing the old-fashioned parsing thing, right? So the next experiment, which is being run as we speak, I have some preliminary results here, but there are, the servers are running hot in Stockholm at present. So we're trying to get away from the hand-coded stuff. So here's an example. This is not legible to you, but there's a long sentence up here. I'll read it out. It says, when he said the investment was safe and secure, they believed what he said was true because he had checked it out. I just randomly picked it from the text set I'm running on. Okay. The search engine view of this sentence is, nothing, then said, then nothing, then investment, safe, secure, believed, said, true, checked. Okay. It's about investments. The constructional skeleton of the utterance is if we pick out the words that the exact complement of that set is that when the was and they what he was because he had it out, right? It doesn't really tell you much, but it tells you something about what's going on. And this is what we hope to discover, some way of figuring out what's going on in a sentence, and then without explicitly combining it with these content words, doing something smart with these things. So what we've been doing here is we put sentences in a word space, again, similarly as previously, and each sentence is then represented with all the words in the sentence plus, picked out triples of stop words in essence. So this sentence, this is a subset of the features, but it would have investment, save, check, believe, all the stuff that was in the leftmost bubble just now, the regular search engine view, plus triples of was because he and when he the and that sort of stuff. All of these triples, which it works out to a number, about the same number as the content words, right? So all of those are used in the word space, and then we try to find which go where. And this is a first preliminary run, and we're running these things and refining these models and putting in directional information as well with a minimum of processing. This needs to be effective. So this is something that runs quite fast. It's pretty much possible to do real-time analysis on large text streams using this sort of technique. So, okay, here we find that words that have to do with people, they go together, which is what the model is built to do. So this is what we expect to find. People, person, man, woman, they go together, right? They should go together. And then stuff like picture and food should not go together, which is fine. This is what we want. And then we find that these three go together with a number of features that have to do with who, where there's a relative clause saying, for instance, some person who did this, right? So it's not surprising at all. This is another bit of content that's sticking to the stop words that's not there. And in this case, pictures and food, they both are very close to a structure that turns out is something that has something to do with people doing the and the, where people are doing conjoining stuff. These never occur together, picture and food, but they all occur in this construction. So this is something we haven't yet applied to a task. So this is the next, this is where I will, in some sense, I would like to stop talking and hear you talking about what tasks you believe might be next. If we think about leaving the task behind the current search task, which is here are 2 words and I want 20 documents or 50,000 documents or 2 documents back. If we leave that task and think about other tasks, what tasks would you like to address? Some of you probably are working on tasks that are, next stage information access. But so given that we have a model that can capture, and this is something we're refining now, right? That can capture the constructional context of words as well as their, immediate semantic context. This sort of model has been around for a while, right? Usually they're inefficiently built, but there are now emerging models that are quite efficient in this sense that you can actually track synonymy of words in some way. So now that we can track, and this of course needs to be done better. This is just a first shot at it. And we can use all kinds of statistical models to do this better as well. But so given that we were able to say, okay, so person and people and man and woman are usually doing this. Not eating and drinking, because that's already captured, but they, for instance, they're likely to be actors in very animate constructions, right? They're likely to want stuff. They're likely to like stuff. They're likely to say things. Whereas food and picture are not likely to like, want, or say, or think things, right? And the constructions between the difference in construction between liking stuff and saying stuff on the one hand, and then just existing or being liked and being eaten on the other hand, being seen on the other hand. This is the sort of structure we're capturing with these simple skeletons, structural skeletons. Again, done without any complex dependency analysis, without any complex processing that involves non-trivial assumptions on categories of the words. It's just presence together, collocational presence, distributional presence. So, what tasks should we try addressing? Someone? Suggestions?
I think in your task the important thing is that you need to first extract some objects, and second thing you need to extract some features of this object. For example, if there is some man, then he may like to drink tea, but he may not like to drink coffee.
Right.
So there is an object.
Okay, so the suggestion here is that we need to distinguish between different types of object. If we think now we're talking about the liking. Right. I'm not going all the way back to the prototypical picture of attitudinal clauses, but you remember we're saying I like sauerkraut, or I dislike something else. So there's usually someone doing the liking, some attitude being expressed, positive or negative, and then there's some object of the liking. That is definitely true, and in this case, I wonder if one might not even be able to find a structure on a micro level, on a granularity level of sentences saying that there are constructions that are very typical for disliking, others that are typical for liking. Because it's quite seldom, and there's anecdotal evidence from other research groups on this. This is not something I've looked at myself, but it's quite seldom you'll find that there is a clause saying, I really like coffee and I really don't like tea. Usually those things are done differently. Saying consumer reviews. People tend not to use negative clauses, for instance. They will say, they liked this, or they will say this was really bad. They will say this is not bad, is rather seldom used. And if it's used, not bad is almost like own lexical item in itself. So there are ways of getting at this, but your suggestion is that we might use this as a bridge, use this structure as a bridge to different likes or dislikes, which certainly is. But so this is a number of different tasks that I have been, playing with, some more concretely than others. But here's so let's see. Sentiment and opinion identification is what we've been talking about now. Another thing that has some serious, let's say, applicational value is quote identification. Who said what when? All right. Find me all quotes that the U.S. president said about submarines in the 1970s. This is the sort of task that actually has some usefulness. Actually, that task probably has less immediate usefulness, but say obvious applications are financial analysis. Find out what people are saying about a certain company or about a certain product. Right? So quote identification is certainly one where constructions, if we go back to this again, if we find constructions, we might actually call saying or uttering a constructional word, and then finding what is being said is certainly one way of doing it. Novelty detection is a well-established task in information access, in empirical experiments in information access. In a data stream, finding out when something new comes along. Right? People are going on and on and on about Egypt, trying to follow the tweets. Some of you, I'm sure, have been following the tweet streams from Egypt, and most of them are just saying the same thing. And then every now and then something happens. Then that is being retweeted by thousands of people, so it's on and on about that new thing. When is something new coming? When does something new come along? Right? You'd only want to see the new ones, not just reformulations of the old ones. All right. So that is a definite task where people, when we express something new, sort of without say in spoken language, we will use a different intonation. If we do it in written language, we'll say stuff like, and besides, this is something new. I will be telling you something new right now, and this is what the new thing is. And there's always a sort of staging for the new thing. This is difficult to establish in text because the staging is done very implicitly and in the organization of the task. And I'm thinking, and this is thinking without really empirical basis, that there might be something to be done here using constructional analysis. Authorship attribution certainly is one of those things where I think I said I'd probably come back to the distinction between difficult and easy tasks in the beginning. Right? Authorship attribution is a really difficult task, like I said. One of the things that is difficult about it is the fact that usually what's studied when we try to do it is word choice. Right? It'll say that this author uses this word and this other author uses that word, and this disputed text has more of that word. But it might be as simple as this author has never written about fishing before, and now he's written about fishing. All right? So topical words are really bad indicators. This is known, right? So then we look at other words, mostly, you know, structural terms. Does this author use because or since? You know, that sort of analysis. Does this author use long sentences or short sentences? And again, this is the sort of thing we've been taught by our teachers how to do. A good author has broken some of those rules, but still based on the things they were told in school, right? So it's very difficult to tease apart the individual variation from the background variation of the language itself. When you write Russian, you do it in this way. And then you can, you know, fool around a little bit around the edges, but mostly you're supposed to write this way. And Sholokhov was he was a good craftsman. He wrote his text in the accepted Russian way of the time. Other authors at the same time did the same. So mostly their texts are, of course, very alike, right? So the thing that you're not taught in school, and the thing where you might distinguish if authors are different, is in the patterning over the entire text. Right, so you'll see it. Some authors will say, will use a series of short statements and then, you know, argue a little bit about it. Pam, 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 ba, da, da, da. You know, that others will say da, la, 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 pam. Right? You yourself probably can, you know, introspectively figure out if you're doing the one or the other, or if you have an even sequence of stuff. This is a theory. It's and an observation, but it's not been successful in real authorship attribution. It sounds nice the way I said, but the thing is, you need more than just, you know, sentence length to be able to say anything useful about this. So what you need to do here is to figure out what feature in text should we be looking for, which might vary across the entire text. Because looking locally is probably useless, because locally you're bound by the conventions and the rules of your language. It's over the entire text where the interesting stuff comes in, right? So that's a place where constructional analysis might well come into play. Authorship attribution isn't all that, you know, purely academic and philological as you might think, because it has great value in a large number of legal cases where you actually need to establish in this huge body of text which of these have been written by, you know, that department in the company. Okay, a large company might be, you know, subject to a court case on, say, manipulating its stock value or something. Then all their texts can be impounded into the court, and someone has to go through them and try to figure out what is being written by whom, and did that go there, and so forth. That's where this sort of technology comes in. Summarization is a familiar task. Has anyone here worked on summarization? No one. Usually people, it's you know, a well-established task. A large number of texts. What's the summary? Give me a summary of this. Okay, so here's a search query. Summarize the results, because I can't, I don't have time to read all of them, right? In some sense, this is very similar to novelty detection. Terminology mining is something we worked on extensively, and myself and my colleagues, finding terms, finding technical terms, finding important words in text, let's put it that way. That, of course, is again, in some sense, something that's fairly simple for people, but very difficult for computers. How will you establish that this term here is a, let's call it an established technical term rather than a ad hoc coinage, right? We might be able to say things that are, in this sort of discourse that we're in now, I might be able to, establish a term, and then we might be a sauerkraut sentence. You all know what a sauerkraut sentence is right now. We can use this in our discussion if we, sit down and have an informal discussion lately, and you will be able to say, I don't agree with what you said about sauerkraut sentences because, and we all know what we're talking about, right? We can coin this technical term. And then we all go home and we forget about sauerkraut sentences forever again until we come back to the same room, and then we can pick up the term because it's lying around on the floor somewhere. But it's never been established as a technical term. How do you know that this is a technical term with a short lifespan or a long lifespan? This is something that is amenable to terminological mining. But I really would like to hear some suggestions. Some of you, I'm sure, are working on interesting tasks. What tasks are some of you working on that involved mindless banging your head against a brick wall of word statistics? This is where analysis of word behavior on another level might come into handy. How many here have thought of using parsers in what they're doing? Whether it's a research task or a school exam? Right. Okay. Has it worked out for you? Shakes. You need to talk to these people. So, tell me about what you're doing then. Do you have a good answer? Do you have a... Build an ontology of the topics in text.
Build an ontology of, terminology. Some kind of terminology that exists in technical text.
Mm-hmm.
I'm trying to, automatically find to build some semantic network
Mm-hmm.
of the terms
Used in text.
for engineers to use them.
Okay. Yes, that sounds very much. Oops. That sounds very much like what I refer to in terminology mining in some sense. Yeah, and quite obviously, occurrence frequency is not enough. It's not good enough to know that this word occurred 5 times or 7 times or 2 times in text. You need more than that to be able to say something about it. And so you're thinking about parsing as a way of finding out.
Well, now I certainly am.
Mm-hmm. Well, yeah, it's quite obvious. You need to find what words are being used in which way. So the question is, what might be the best way of finding out, and what do you need to do it? And it's unnecessary to parse the entire text if what you're doing is picking out certain terms that behave in a certain way. So this is I have no answer. I'm just curious, Other difficult tasks? I mean, that is obviously a difficult task.
I've been thinking lately about text clustering based on some semantic concepts. I thought it might be useful for some interesting texts as like news feeds,
Mm-hmm.
where they are short and they contain a lot of facts.
So clustering newsfeed texts that are short and contain a lot of facts. And of course that clustering is mainly intended to be topical, right? So,
Yes.
so this is about that topic and this is about that topic. And so what would a typical challenge be there? Is this topic mentioned in passing or is it really topical?
The challenge is to merge a few unused documents into one topic.
Mm-hmm.
So it's
It works badly with a bag of words. Okay. And so the question is, might one be able to find topically relevant structures that are in the text that are give you an extra feature for categorizing them better? Well, I guess that would depend on, of course, if there is a certain type of register, certain language use in that topical category. It certainly would be different between, say, sports and finance news. But different types of finance news. Maybe that's certainly an experiment. So anyway, what I'm saying here is that, and these examples we talked about are in the same vein. I mean, if all you want to do is build a very efficient index, it's probably not worth doing much more than counting every word in the text and throwing out the ones that are uninteresting. But if what you want to do is more than that, then you need to do something else, which would be, these are examples of doing something more. And of course there are obvious tasks that have to do with dialogue and translation, but I'm talking about information access primarily. And the task of, organizing a large body of information so that it's useful for some human task. And these are ones that I've myself played with, but I think that there are more. And so this is what I would like you to remember from what I've been saying. Constructional models have the suitable granularity for simple, difficult tasks. Right. I'm not saying that this is useful for, say, translation, which is a difficult task. But for simple, difficult tasks, namely tasks that are only just a little bit beyond what we do today in search, we can use constructional models because they have a level of abstraction that's not very complex to work with. There's a simple methodology to test. We can still use search engines. In essence, what we've done in our experiments is we've added a few words to each sentence to describe their patterns. We observe a pattern, and then we just say, okay, this is just another feature, and we treat it just like words. Our claim is, and the third point here is, on a theoretically more contentious level, we say that these features are not, they don't depend on the word occurrence features. The words aren't there first. Neither is the pattern. They're on the same level. That this is sort of related to information extraction. And I think that if we do this well, those of us who have half a foot still left in linguistics can go back and finally tell them something. Because linguists tend not to work with information access, which is sort of weird. It would be fun to go back to my old department and say, look here, I know something about language you don't. And this is because I have machines that work with a lot of language and you don't. Right? So there's a bunch of interesting questions that are worth each in themselves, a PhD dissertation or two. And there are people working on this sort of things. Most of the people who work on what's called constructional grammar are real linguists in the sense that they actually work with, rather small bodies of text and put great amounts of work into modeling those small bodies of text. But it's finally a linguistic theory that actually is generalizable to a larger data set, larger corpora, larger collections of text, without it being obvious to the engineer that it will never work. I mean, in this case, you can do a very low-key level of analysis and hope that something happens. And this last point here, the third point is something we just now talked about. I have some ideas here, and I hope to sort of spread the word here so that you think about what I would like to see is that people, when they think, okay, this is hard to do with frequencies, I might try parsing, and then someone else says, no, don't, it never works. That people might reconsider and think that there are ways of making linguistic analysis work for you. You don't need to do the full thing based on theories that might not be the right theories. And this fifth point is something this is sort of the thing we're working on. Let me just go back, and this sort of thing is where we're playing with learning constructions automatically. What we need to do is to have the appropriate features here rather than these triples, because these are quite obviously just a first stand-in. And the interesting thing we find is that some of these, triples don't turn out to be similar, but they, diverge in our representation. And we'd like people to play with this using other representations, because I'm using the one I'm using for other stuff as well. So that's more or less what I wanted to say, and I'm very glad to discuss this further in various synchronous and asynchronous ways. I mean, primarily I'm very easily available on the net, so any discussions you want to, ideas that emerge further on, I'll be glad to discuss them in many different ways. But I would like to see people experiment with this sort of thinking, and not just always think about word occurrences as being the primary thing that is in the clause. And immediate questions are, of course, immediately welcome.
In languages, we have words like la 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 and so on that describe sounds, and how to classify them.
So the question is, words that are not typically in the lexicon, let's put it that way, immediately coin, the example was la la la, so words that just happen. I would expect that those words occur in certain points in discourse, so that they're actually quite predictable. For instance, here's a typical example. There I was, standing talking to these people. I was going la 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 la, and he was going on about this thing. He was going la 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 as well. That's the way you describe discourse. It's like a variable, and in place of la la la, there might be whatever in that place. So I'm assuming that if you have a large number of texts with various words like that, those words will all seem to be very like each other if you have a distributional analysis over them. If what you do is model words by how they appear in text, those words would be very much like each other. Of course, if you want to build a parser, a full parser that says, okay, it will react because it's an unknown word. And if it's a modern useful parser, it will say, here's an unknown word. It's in a location that's typically a noun in accusative case. And then it will just, provisionally target la 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 as being a noun in accusative case, if it's Russian we're talking about. But, I mean, that is a very, let's say, that is a very important question to solve if what we want to do is work with text that has not been edited by editors. If we want to work on tweets, if we want to work on blogs, if we want to work on, actually, if we want to work on newsprint, because newsprint typically today is not edited. It's just input directly by the journalist. It's not corrected by other people anymore. There are comments, yes. Okay, so here's a very concrete task. I don't know how it is here in Russia, but in Sweden it's important for the newspaper to keep the comments clean. Not because censorship, yes, well, in some sense. It's not about annoying people as much as that there is a law that says what's published in a newspaper is the responsibility of the editor. Right, so if there are obvious untruths that could be liable for, or inciting violence or whatever, there's a law against publishing this. The same law as in print applies to the comments. So there are people today that actually read the comments and then they remove comments that are annoying, which is, of course, a really dull job. You'd like someone else to do it, a computer preferably. And it shouldn't be very difficult to observe that this comment seems to be the wrong kind of comment. Not topically, but structurally. And then, of course, you will never hit all of them. You might get a really, something coming in under the radar. But that's so that comments are an example. These are not edited; they're thrown in off the top of your head. And if your analysis tool breaks as soon as it encounters a word it has never seen before, you're stuck. Or if what you want to do is summarize all the tweets about Egypt, if it breaks down the minute it finds a new word, if la 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 comes in, right, it must handle it in some useful way, all right? Otherwise you will never be able, you will always stop, because there's always a word in Arabic. Even though most of the tweets are in English, there will be something there, right? So you need to be sensitive to the fact that there will be new words and there will be misspellings. I have some really fun slides on what are the closest, semantically closest words to words like love on the net, on net text. Like, fine, but enjoy, recommend, which is good because this is useful for, say, product tracking, because product tracking, recommend is one of the most valuable words there is. But also love spelt with 2 O's, or 3 O's, or 4 O's, or 5 O's, right? This is not something you would have expected. But of course, people will, I love my, Nissan. So this is the sort of thing you will encounter. And when we looked at recommend, which was, a word we understood would be useful for us in tracking consumer opinion about products, we found that recommend, the closest words to recommend, well, love was there and like was there, but much closer were a number of misspellings. Recommend is very difficult to spell for most English speakers, right? It has 2 M's and 1 C. But every permutation of doubling and there was and some of them were obviously typos, right? People just mistyping. So some were artifacts of the keyboard, right? But some were artifacts of English language schooling, and it's useful to be able to track them, like la la la.
If some people do mistakes in the sentences, it's not like text in internet has some mistakes.
Mm-hmm. Well, since we don't have any norms built in the way we do things, mistakes just aren't noticeable. There's no difference between a correct and a mistaken sentence in some sense. The mistaken sentence, let's, now, did I lose my thing? Here. If we go back and look at this picture, which is illegible, the first thing is a fairly long and complex sentence, and I selected it more or less at random from the text I was running. I was running yesterday an experiment. When he said the investment was safe and secure, they believed what he said was true because he had checked it out. Okay, this is a fairly interesting and a useful sentence in some sense, because it has content which is quite valuable, right? It says someone said something good about something, and they, some unnamed they, believed what he said because of some other reason. Okay, so it's, in general, it might be useful to be able to track sentence said. Let's see, when someone says X, person Y, or in this case a group Y, believes X because something, right? This is a frame you might, it's probably easy to persuade you that it's a useful thing to track this sort of things, because this might be useful for summarization or for financial analysis or for legal analysis or whatever. If we can find all sentences where people believe something because someone else said something, that would be fine, right? Now, in our model, your question was, how does our model handle mistakes? Now, I would be happy to say more about our model if we really had a model. We don't really have a model yet. We're still building it, but what I will say something is that if there were errors in this clause, it shouldn't matter, because if what the in the sentence, because this sentence has several clauses, and if we can find this setup of clauses saying someone believes something and then a because and then something else. If there are small typing errors or you know, something there, those we ought to be able to handle. If we don't, we're doing something wrong. Because this is a fairly basic human thing to say, right? Says something, Y believes it, because Okay, this is something we say every day in various ways, right? We should be able to track this sort of expression. And if people make mistypings when they express this, that, or if, you know, if I say something like this, I believe that restaurant X is good because I read it on a, you know, scuzzy web page. If I repeat myself when I say this, or, you know, mispronounce the name of the restaurant because it's a Russian restaurant, you shouldn't disbelieve me because of that. You shouldn't stop listening then, right? You should at least take in the full construction and then judge it for its content rather than. So any model, so your question is, how does our model handle mistakes? When we have a model, not just experiments, it will handle mistakes. It must, because otherwise it's not doing what I want it to do. Mistakes are inherent.
My question was, what's the recommendation to do? First of all, clear text from mistakes, and then use model.
No. So the question was, should one first clear the text from mistakes and then use a model, or the other way around? No, I would say. No, I would say the model must be built so that you can feed in any kind of garbled text. And if it's really weird, the model will not understand it and forget about it. But because the text, there's no way of writing a proper grammar for tweets, right? You'll just have to accept what comes in. The data never lies, right? This is something linguists have paid too little attention to. That's, you know, Saussure's and Chomsky's fault.
How many patterns do you plan to use to describe in your model?
I would love to be able to give a very concrete answer, and there's a little anecdote here. When I was a very young graduate student, I went to a big conference, and Igor Melchuk gave a talk at the conference, and which I liked a lot, on lexical semantics, which I'm sure some of you have read at university. And then later on at the banquet, after some wine, he stood up and then he gave another talk, more or less on the same topic, uninvited, unexpected, and it was actually much better than the first one. And then he said, I have now discovered 68 lexical functions. And I think I maybe will discover 1 or 2 or 3 more. So he was able to give a number, okay. But I remember at the time thinking, I don't quite believe the exactitude of that number. But in some sense, I wouldn't want to start answering that question, how many patterns would one need? And on the other hand, something in me itches to start thinking about it properly, because there's only a limited amount of stuff people actually say, right? We can say it in unbounded ways, right? There's no way of figuring out all the allowable utterances people are able to do, but we can actually fairly well figure out what people want to say, right? And this is what Melchuk was saying, essentially, that they're on a micro level, lexical functions are, you know, very local in text, but on a, you know, a human behavioral level, how many things do you think people actually say? It's not 1 million. It's more than 10, and it's less than 1 million. Right? Okay.
Okay, thank you. And do you think that there are kind of meta patterns that you will on basis of? Oh yeah. I should, you know, discuss more about this. Okay, here's an example of patterns from this example sentence. When he said the investment was safe, when is one of these. I mean, I don't believe we will be doing trigrams once we start working on it properly, because that's just a first placeholder for what we want to be doing. But here's a he there. I don't think the he is significant in any important way. It should be he, she, they, it. Maybe not it. He, she, people, man, woman, boy, child, girl. You know, something animate
right? And I think there, that sort of meta pattern certainly should evolve. Once we see that certain patterns seem to be alike, we should probably generalize from them. And we, in fact, have experimented a little bit with it as well. But, just like it would be very interesting to generalize investment into a number of, money words. These patterns should be generalized as well. But I wouldn't want to do it beforehand because, of course, as a linguist, you know too much about grammar and lexical categories, and then I would like to use one of these, 12 categories that are around and say, okay, let's put personal pronouns there, and articles there, and conjunctions there, and then we have a meta pattern. But that's unfounded. Then we would lose a lot of information that hopefully is there in the micro behavior of the patterns. So I want to see where they go first before I start working on them.
There's a test called GMAT, and in the final section of the test there's a safe writing section, and once you've done that you will be graded by a human and by a computer. And then if the difference between your grade and, the difference between the grade of a human and the computer is more than one score, then the third human, or the second human will estimate it. So the question, first, this technology works very well, and in most of the cases, computer is right. And the question is, are you familiar with that mysterious program?
And can I give you a code which will beat the GMAT? Okay, so the question is, I'm saying this for the benefit of the tape. The question is, the GMAT test is automatically graded, and that works quite well compared to human grading. So how does that work? I have no idea, but I can think of, I can assume that it has certain fairly strong stylistic markers in them. I know that the people who develop stuff for GMAT often show up at,
It's very secret. They don't open secrets. But there are several assumptions, and one of the assumptions is that they have some predefined number of essays for each grade possible, and then once it's scanning your essay, it's just comparing with patterns, and it's trying to find the closest essay. But it's very difficult to do, and there are a lot of questions. It has a practical science. If you know how it works, you can have higher grades, but it's very difficult to understand.
I presume that the best way, so since the automatic assessment appears to be quite successful, and it's probably, like you say, it's probably vectored towards a standard set of useful and less useful answers. I guess the correct way of testing that would be to submit a number of fake entries and see.
Test costs $250.
So you need corporate sponsorship to be able to do this. No, I have no idea how to do it, but of course I would be. I've heard the folks from ETS, I believe the company is called GMAC. Okay, that's TOEFL. Yeah, that's TOEFL, right? Asking questions like this before, and I've always been very suspicious of the fact. I've doubted the possibility of actually building good tools to do this. But it works, and probably it works for a large enough proportion of the case. And if the difference is too large between the human and the automatic assessor, then of course and then you look at it again. Okay, which is it's a very safe procedure. And even if you do half of them again, you still are saving a lot of manpower.
Yeah.
So I guess it works for the typical cases, which is good enough. But I wonder what they do. I have no idea.
One thing that I'm doing now is analyzing the search queries. And what I found out is that the structure that people use when they formulate just something to search is quite different from what is usually used in texts. So it makes the comparison quite difficult. And I try to find out a phrase from a search query in the text, and I just compare one with another.
Right, so the observation is that search queries are different than the best target texts.
Yes.
Right.
The problem is really in the structure.
Right. So the structure of a search query is very different, right? So you can't use the structure of the search query.
Exactly. And what I thought about is to try to take the text from some paragraph and then to rearrange the words
if they would be entered in the search query. I don't think that is really an easy task.
So I mean, retrieve the words. If you have a search query and retrieve.
So the problem is, for example, that people, when they search something, they ignore the declension cases.
Right.
They just write Toyota price.
Right.
They don't write price of Toyota.
Right.
So this problem is really kind of thing that you'll deal with, I think, with structures. And
So first you need to find text with price and Toyota and see what typical constructions they co-occur in, and then you can start looking for those structures. That means 2 cycles.
exactly. So to do the correct match, one can either take the search query and reformulate the words so they form a correct structure, or one can start with the text and mangle the words so they form something like a search query.
Another way would be, of course, to use go back to the question: how many patterns do you need? When people say price X, you can have a predefined set of patterns that fit that query, because when people say price X, they usually are asking for the price of a product. So then you will be able to match those immediately through a pattern. So you don't need to construct this pattern every time in interactive search, presumably.
Yes, but the number of patterns is really high, and so in order to analyze all the search queries, I don't think that 10 or 100 patterns that can be manually edited will suffice. So it's really a problem of...
Well, you need to pick the most frequent ones and accept that savings without trying to go for 100%, presumably.
And so the information about how the search queries are built is really something completely different from how the...
That has certainly been known for a while, and say the standard evaluations often have had very well formulated search queries saying, find me documents that are about this and not about that, and this is not the way people search. So
it's very interesting case when the sentence has a reference to another part of the text.
well, this certainly is an example of that.
I mean, as we said, or something, as we said above, and the main idea is completely in the above. So it can be difficult to construct, to get a construction of the whole idea.
Right. So the thing is, sentences sometimes refer back to what's been said before, and sometimes that is crucial for understanding the sentence. The sentence in isolation doesn't carry enough information, and so the question is, I guess, if one should, either copy down when one sees this happen, or just accept the fact that if you have, actually, what one probably should think about is that the sentence is not the unit, but the larger utterance is. You present, I will be talking about A and B and C, and then I talk a little bit about something else, and then I say going back to A, B, and C. So there's sort of a threaded structure. I have no idea how to work with that. It's nowhere on the level of text.
I can comment on that from my total experience. There are some types of questions, the types of questions like this one, and for example, there's sentence number 1, sentence number 2, and there is sentence which can be inserted between those 2 sentences, and there are 4 options. Have to guess which sentence matches the better. So they advise you to use pronouns or verbs. For example, if you have in the 3rd sentence like these items or this is referred as pronouns, so we have to find some noun. And as the previous man said, if we have something like as it was said before, we have to find for verb. If I have at least this classification, we can deal with this problem much better. And then we can just try to use some, heuristics or something else. But at least if we identify the category of the words, it can help you out.
But that is also on a micro level, but saying that if we still think that the task we're doing is, that is the correct way of doing it if you're on a micro level and you want to fit arguments together with the terms you're working with. But if what you want to do is do something larger, say, we really aren't interested at all in the content of the text, say authorship attribution, my current favorite task, right? Then this is not a problem. It's just that here's another pattern. Here's a textuality pattern. Some authors just, string clauses together and never refer back in them properly, and that's hard reading. It's schoolboy writing, right? Whereas some authors, they constantly go back and said, as I just said, and going back to what I just said, and as above, and so forth, which is also hard reading.
This problem lies more in semantic domain than in syntactic analysis.
Right, but I would. So the observation is that this is more in the semantic domain rather than the syntactic analysis, and I would like to stress the fact that I don't see a difference between the two, because saying that you first do one thing and then you have another process which looks at the output of the first. I don't think there's any real plausibility in claiming that we have one machine which does one thing and another machine. It probably should be an immediate matching in some sense, but this is. That's something that you can debate without ever needing to agree.
I have a question about ambiguous sentences.
Ambiguity, yeah.
How will you handle these? You have several patterns.
So how would one handle ambiguous sentences? Some constructions are ambiguous in themselves, right? And so how would one want to handle this? Certainly for English, which is morphologically quite, impoverished, but English is a special case where the organization is mostly word order, right? And in some languages, stuff isn't ambiguous, which is ambiguous, structurally ambiguous in English. Like I see a man with a telescope being the perfect example. Okay, so the question is how. I don't see that is a problem on the pattern level. It's not a structural problem. It is an ambiguous structure, but the choice between the different readings is determined by the semantics of the entire discourse in some sense. And presumably. Okay, here's an example. Here's a question that I sometimes posed for people back when I was teaching more than I do today. The first lecture in basic linguistics, I asked people, okay, one of the assignments at the end of the class will be to produce an ambiguous sentence that you have encountered, not formulated yourself, but find one. And it's quite difficult to find ambiguous sentences. I mean, encountering them in real life, because you don't even notice them when they pass by, right? So ambiguity is not a real-life problem for most people. It's only a problem if you want to look at a sentence in isolation, and those occur fairly seldom. They do. I mean, once a year, right? On that order, right? Unless you're a very, very careful person. If you find ambiguous sentences every day, which is, theoretically possible, I would assume your friends hate you, because this means, stopping discourse very often and saying, okay, were you holding the telescope or was the man holding the telescope? And we have similar ambiguities in Swedish, and I'm sure there are several structural ambiguities in Russian, and I'm guessing that many of those have to do with prepositional attachment as well, because that is typically a ambiguity generator. But so the question is, how do we resolve them as people? That's the way I would go about resolving them if I needed to in computation. And this is presumably done by selectional restrictions, mostly. So that typically an instrument is something that is being used by someone doing something. So if I see a man with a telescope, it's likely that the telescope is being used by me rather than carried by the man. But there's no good answer for ambiguity, except to say that maybe it isn't a big problem, which is what I'm trying to say, just hiding it.
Your presentation included kind of diagram about attitude and some constructions like time shift and so on.
Let's see if we can find this.
positive attitude,
Mhm.
time shift, tense shift.
Yes.
And why why should such
Okay, so
do you understand as
right. It's a this is a so the question is, why is there any good explanation for why these seemingly only structural features actually correlate with something that is more on a pragmatic level than structural level? How come that we can even find this? And well, the thing is, there is usually an explanation if you look at a number of these things, say predicate clauses, things like something is something. That is a construction that can be used for a lot of things, but it's very often used for something attitudinal. Something is good. So this is frequency based, right? So it doesn't mean deterministically that is clauses are. So the frequency of these is clauses will, edge towards the. So the x-axis here is the attitude axis. These being neutral clauses like, sun shines, and here being stuff like, I really like sauerkraut. Sauerkraut is really good. So some of these things will end up here. So negation here is weirdly enough far from negative clauses. That really made us worried for a while, but it turns out negative attitudinal clauses seldom use negation. It's actually not too weird when you think of it, when you formulate a few negative clauses. Relative clauses, let's see. I don't want to generate explanations on the fly because I will mess them up, but because I don't have the data in front of me. But the catchphrase, of course, the slogan is that the data doesn't lie, right? So there is a correlation. And for instance, transitive mix and tense shift, those are features of complex clauses, complex sentences, right? Where there's a matrix clause and a subclause. And so the mix saying that there's one of them is transitive and the other one isn't. I believe that something shines, right? I like that the sun shines. That would be a transitive mix. Those things go together because the complexity of the sentences involve more stuff. And that stuff is likely to be attitudinal to some extent. So very simple sentences tend not to be attitudinal. The extreme case being sun shines, right?
Yes, I understand what might be the difference between attitude and non-attitude, but I have no idea why should be some structural relation with positive and negative.
Okay, so part of that has to do. With well, let's say the red things are observations from the data. The black things are human assessors tagging data with positive, negative, and neutral. Sometimes one disagrees with those assessments. So these are not, these are not gold standard in the really 24-karat way. But it's a few thousand sentences, so there is data here, enough data for us to be able to say something. So thinking about it, the positive and neutral, the neutral I don't like at all, the category, because it was made by assessors who weren't sure what they were tagging, really. But that there's a difference between positive and negative shouldn't be all that surprising, really. If you think about people saying positive things and negative things, those are typically uttered in different ways. It's not just adding this in front of like. Certainly there are sentences that are, just one bit difference when you flip. Here's a sentence and I just flip the switch and then now it's negative. But typically negative stuff is couched in polite language and you don't really want to be unpleasant. This is also edited text. I should remind you of that. This is not blog text. Which is a pity, because blog text is different. But we've used blog text as well, and even there we find that people are negative in different ways than they are positive.
How do you define the sets or features you should use?
Well, we did what I first said we shouldn't be doing. We sat down and we used our linguistic intuitions, namely our linguistic schooling, and we thought about it for a while. And we had a decent parser which we used, and we looked at some sentences. And then one of my colleagues hand coded an extractor, which based on a number of hunches and assumptions we had, stuff like I was just talking about, that transitivity mix. Complex clauses like this. Some of the things we tried to look for was a large number of adverbials, figuring that they would probably encode a lot of stuff. That didn't pan out as well as we hoped. So here, what is it? Something like a dozen features. We tried maybe 50. But these were all hand-coded, and a non-trivial effort was put into hand-coding them. So this is what we want to get rid of, in some sense. So, based on intuitions is the short answer to your question.
Have you tried that on text with humor, for example, jokes?
No. No, that would be fun, but no, we haven't.
Standard example in Russian, I have stayed in a traffic jam in Moscow. Two guys, they blocked the road. We have words like good guys, but we can't understand that it's a negative from the text. So maybe...
Right, so of course humor is different, because humor often, humorous sentences often willfully break down some of the conventions of that's the whole point of humor. Also ironic clauses, and there's all kinds of stuff that goes on where people, fool around with the rules. But still, I don't know. I mean, we've done sentiment analysis for a while, played with it, to find consumer opinions, and then people always ask us, so how do you do with negation? How do you handle negation? How do you handle irony? How do you handle sarcasm? And we don't, because people aren't sarcastic. They might be for one sentence, right? They will say, okay, so this is another great product by Apple. Not. And then they will go on and tell why they don't like it. You don't write an entire review in a sarcastic tone, because people won't just read it.
Maybe I have missed it, but I want to ask what data set was used for this diagram and task?
For this diagram, hang on, it's here somewhere. I skipped it because there was a large number of numbers there which weren't too fun to talk about. Let's see, there. Okay, so the question was, what's the data set for the task in this diagram? It's 2 years of NTCIR data. NTCIR is a standard information retrieval evaluation task, goes every 18 months, run by the Japanese Institute of Informatics Research. And number 6 was a training data the year we participated. Number 7 was the real data for that year. 6 was rather less well put together, so now I believe that they actually now say from NTCIR, don't use 6, use 7 and 8 instead. We didn't run it on 8. And this is a number of newspaper sentences, so a medium-sized number of newspaper sentences, not anything like huge numbers of real data, and they were hand categorized for being positive, negative, neutral, or no attitude. SEM eval was an experiment for a workshop, a Connell workshop. I seem to remember 250 news headlines. Like I said, let's see, these are examples of the SEM eval text. So the texts were just a few words. So even there we found some purchase. And MPQA is a standard test set by Jenny Sweeb from the US. You can download it, and it has tagged for positive and negative, and I think neutral. So these are standard text. They're all downloadable from places. And there are other test sets today. This was done a couple of years ago.
It's not a secret that today more and more text which we consume comes from websites like Facebook or Twitter. In my opinion, the main difference between that information and the can understand who wrote that. We can read the reaction, comments.
Mm.
We have time. For example, you asked us how you can distinguish the case when we have something new on Twitter. But if we try to analyze the frequency of tweets,
Mhm.
probably if hosting bar just resigned, we will see hundreds of tweets, and we can analyze. We can a little bit different approach to analysis. We can use some simpler methods, but they can be more easier to implement and more effective. So, did you think about kind of future directions of your research and how your current models are adaptable to these new changes? And can we have some breakthrough in this direction?
Well, certainly we're very interested in how to process what we call new text, non-edited text. That is actually that's the only text we process at present. We don't use news text at all. And that is one of the motivations for not using a standard knowledge-intensive analysis tool, because since everything breaks down when it encounters weird language, we want to use stuff that doesn't break down. So one of the points of using constructional analysis is that it's low footprint. There's fairly little knowledge put in beforehand, fairly little processing done on the fly. It can handle larger volumes because of that. Well, depending on how you encode it, of course. And this specific experiment was, a fairly complex analysis. But for the let's go there, these things, they just rush right through. It doesn't cost you hardly any processing cycles to do this. You traverse the sentences one by one. And this is something we need to do to be able to use social media text, which are completely unedited and so forth. Now, what we don't have is one of the important things you said: how could we understand them without using the context, right? And there's no contextual analysis in these sort of sentences. So we need to model the context somehow. Otherwise, they will be uninteresting or, impossible to understand, because they will be saying, about Egypt, there will be a topic sign Egypt, and then it will say, now it's happening, right? Okay? Unless you have a date stamp on that, and preferably a geolocation, it's not very interesting to find. It might be, a handball game between Egypt and Sweden. So certainly we need to contextualize the analysis as well.
Can you please tell more about real implementations of this model, like maybe product names?
So how are our models implemented? For product. Okay, so this is something that has mostly to do with one of my identities that as a partner in a recent startup. And what we do is we do one of the things we like to do is product name analysis. So looking at product reputation. What we do is this sort of analysis, given that sort of bubbles in the text, we do this. We find a web of association between terms. And this is, of course, interesting if one of those bubbles is a product name. It's useful to, find what the associative strength between different notions are. This is something we run through a very similar process that what I was describing here, but I didn't go into the technology in any great detail. Let's see. There the one, number 4. So that's the Q thing there. We use a semantic word space based on distributional analysis. Basically, what we do is we calculate a contextual window for each word, and we figure out what it associates with, and we do it in a processually very efficient way. And I would love to talk about it, but it will take me, an hour or so, and I think I may exhaust your patience in doing so. But certainly, it's possible to do that on a large scale today. And we haven't tried Russian, but at some point we will. So the major idea for our sake is that given, let's say, go back to one of these feature pictures. Okay, so given a number of features for a sentence, we want this system we run to be able to accept constructional features on just as it would words, because we know how to process words. And we want to claim that these patterns are also types of communicative objects. They're also words in some sense. Or that words and patterns are the same sort of object. So this is the way we process them. So on a sort of macro level, what we do is we extract features from a sentence. Those features can be lexical items or patterns or meta patterns or whatnot. And then we process them in the same way based on their distributional statistic. This one tends to co-occur with that. Okay, so let's say, so the word, for instance, we would likely find a fairly strong association between believe and true, right? Because they would, co-occur quite often. I haven't tested this fact, but it's likely to be there.
You can see it with triple O. So I think it's possible to view it as just one relation between these two words. So just lexical level of relation. Second level of relation could be the syntactic level. For example, we can say terrorists attacked victims, or we can say victims were attacked by terrorists. So we can see the paraphrasing at the syntactic level. Similarly, you can do paraphrasing at the semantic level. Like, for example, you have word like attack, then you have arguments like who, attacked when, attacked where. Right. So, and you can phrase sentences in different ways. This will be a paraphrasing, but just based on the knowledge between about relations between the word attack and its arguments, that it must have these arguments. And you can handle the paraphrasings at the semantic level. And the next level is the discourse level for relations. So this is about what to do. So you have paraphrasing. If your entities occur in different clauses of a single sentence or different sentences in the text. Yes. And I think it's possible to view this program as a program of paraphrasing at different levels. So if you just consider relations between words, right, then these relations become invariant, yes, and they become invariant at different levels. Yes.
Right, but
yes. And then once you got this text and Twitter, you just try to figure out what the relations are at different levels.
yeah, but those levels you're mentioning here, the semantic, the syntactic, the lexical, and the discourse level, they're all motivated by processing to some extent. And yes, but still, you would want to think about them. They're still there in the data in some extent. I mean, the text itself, the tweet itself, doesn't have multiple levels of understanding in itself. It's just there and it's understood as a whole. So an ideal model, in my mind, would want to represent all those different levels simultaneously, right?
Correct. And I think as a whole, if you view it as a whole, we need to have out of text, we need to figure out what the objects are, what are relations between these objects, right? And then we need to have the mosaic of these objects. And once we have this mosaic, once we put in some new text, we can map it to this mosaic. I think this will kind of clear.
Right. Yeah, so if you have a knowledge representation to map towards, you're certainly then you can certainly put in any kind of weird text and hope to match it with the best match to some extent. That certainly is one way of ideally your knowledge representation will change with the text you get, so it'll accept the next one without as much hard work, but we're not there yet.
That's what I was studying in my PhD thesis.
Okay.
Here we see either lexical items, lexical words, or some bundles of functional words, and other some bundles of both lexical and functional words like if, investment.
Oh yeah, there's this first experiment on skeletal patterns that I give here. We used a more or less a standard stop list to categorize some, to assign a special status to some of these words. Let's put these as structural words. That is the wrong way to do it, obviously. I mean, some of these, for instance, one of the obvious things, since this was newsy type text, newsprint-like text, saying is a structural word to some extent in this sort of text. I mean, a large proportion of these sentences is someone said something. It's organizing the discourse in a way that has very little to do with speaking and saying. It's just a way of organizing stuff. So these triples that we've now for convenience have used a stop list to generate, they should be generated for all kinds of things. And like I said previously on the question of meta patterns, some of these items should be generalized. So I would envision these patterns to be patterns of the type using a palette of lexical categories that we don't have currently, but probably with a much larger palette than the 10 or 12 we've been taught in school. But the palette would include categories such as animates or people or organizations are certainly, and then thinking, wishing, and categories such as irreality or past tense and that sort of thing. So on a very mixed level of things we might want to say, they should be represented in these patterns. And these are just the first placeholders for patterns, these features. So I think this text here, there should be something like believing and because are certainly, because is certainly a pattern. I just have no easy way of extracting it automatically, and I don't want to go in and do it manually at present. So there should be something like when something because something, something like that, right? That's a reasonable pattern. When someone said something, that's another pattern. So there's no way of deciding a priori what terms are, frames and what terms are content. This is probably learnable from distributional statistics. This is at least my hypothesis.
Can I just clarify whether or not I correctly understood the previous discussion between the man and the PhD? So basically you are saying that your approach is to not make significant distinction between words and patterns, and that man said that it is easier to analyze the information if it's presented in a hierarchical way. It's kind of divide and conquer.
I think that your observation is that if you have a well-represented, let's say, target ontology of things you might want to be looking for, a pattern on various different levels, it's easier to match, let's say, weird input to some of these analysis levels if you have this. And I think what we were just talking about here, where you have a mix of various levels, my claim would be I wouldn't want to build a system with several different levels. I would like to mix those levels. But the observation is correct, is that if you have a pattern for, say, terrorist attacks, which was the example you gave, if you have something coming in which seems to be about it, but it's in the eye of the processing tool, it's an anomalous utterance. It doesn't fit the system. If you know that it must fit one of these by virtue of the content words, then you shoehorn it through in some way, right? So there are various different...
Levels.
various different levels of analysis. I would like to get rid of the levels.
Yeah, and your approach is to get rid and to have such kind of flat model. And what I want to say here is we can draw an analogy with, basically what we're doing here is trying to teach the computer to understand the language, right? So we can learn from the nature and we can learn how a human learning new language when it's not the first native language. And there are two different approaches. One people say, okay, I have to go to another country, just speak the language and the knowledge will just come to you. And other people say you have to buy 100 books and just study grammar and it will work out. But actually none of these approaches are correct. And the better way to learn language is to combine these two methodologies. I think we can say, in some sense, the same thing with these talk, or maybe I'm wrong.
Yes, well, certainly, I mean, this is exactly what I was thinking of when we were talking just now about this mixture of various things here. Certainly, if I have a pattern saying animate, cognitive word, that is and the last is an attitude word. It would cover a lot of sentences saying people think that food is nice, right, or something, right? And that in itself, of course, it covers several levels because it has generalized across the lexical level. It has a discourse aspect to it, and so forth. So what I would be saying is that I would want a model which can capture several different types of semantic relation in itself. It doesn't need to, it doesn't need to defer to another model to do some other processing to be able to do it later. But I mean, this is to a large extent, this is a question of how you envision your processing, and certainly, I mean, that's important in itself, but maybe not at the first design stage.
I guess that if you want to have some patterns like when, and whom, because,
Mm-hmm.
you have to use some parts to pass the text. Because
In some sense, yes.
You have too many wrong results.
Mm.
Too many wrong hits for this pattern, because these words have some other functions, and it's because it's embedded in relative clause or something like this, it's not valid.
Yeah, so well, if I want to make sure I get it right, I need to track that this pattern looks in a certain way. And there will be numerous variations of this pattern. So there needs to be some level of abstraction if I want to capture all the similar ones. And I have no simple answer as to how to do it. The constructional framework, construction grammar framework, is rather, offhand about it, saying, okay, and we can postulate, a constituent here, which is magically built by some other component, again, going back to levels and so forth. But I would want to say that, okay, very infrequent patterns are probably not as easily captured. But in general case, if you have a frame saying when, and then there's blah, 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 they, blah, 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 and this frame would have to, cope with most of what's uttered. Because, again, I'm not looking at present to build a tool to analyze sentences and in such detail, such as information extraction sentences are working. I'm looking to find the patterns that have some sort of functional power, going back to this, that one. So I don't mind that I miss, 2/3 of the sentences if I still can capture a strong correlation that's good enough for some task. And these black things here represent the task. In this case, the task is identifying attitudinal sentences. I might find better tasks. I mean, one might be Sholokhov, and the other thing might be, some other, I forget what the name of the other author who's claimed to have written the stuff is. So there might be, the name Sholokhov and the other name in the same graph. Then, of course, I don't mind that I miss, half of the sentences, as long as I can find a correlation. Then again, another category might be the real information extraction task, and then of course I need to be very exact. Then I need more analysis. But I'm trying to stay motivated by some task.
One more question about these patterns you found. I've been thinking about inference engines.
Mm-hmm.
Well, there in the expert system there is a thing. Well, I think you know, but someone could missed it out. There is a thing called a rule when there's some kind of placeholders for some statements, and then there is a statement which has a number which is called a certainty factor. For example, if you add 2 and 2, you get 4. Well, and if your display doesn't work and your mouse doesn't work, maybe you should check if the cable is in the computer. It's called a rule. If we get a human typing in some situation in a formal way, answering questions about what is wrong with his computer, this rule in the inference engine helps to come up with a solution.
Okay.
These patterns you've found, I guess, came up with. I think they're much alike, this rule, because this is something that has, to some sense, placeholders for actual words, and the whole pattern represents some way things interact with each other or relate to each other. Maybe these statistics and the experiments you've been working with, maybe there is a way to make up a set of rules to make some inference based on the patterns.
Right. Well, that's if you have a set of patterns that fit a task, they certainly are very close to this. For instance, a set of patterns that might be interesting is a consumer hotline, right? People writing in, more or less in the way you are. I know for certain that a very commercially useful pattern might be, okay, let's try to identify if the consumer is very frustrated and very angry. Because then let's put a human on the line now, right? And that's not all that common, but if you can figure out the 10% of customers that are really annoyed, you'll make them very much happier if they... So, can you find a pattern for someone being really annoyed? I think that isn't too difficult, actually. So that's an inference rule right there. And then if you're able to capture, 2/3 of the cases using simple rules like that, and then you capture the really annoyed ones using another rule, then you're already doing something useful. But the inference rule is a good example of, in this case, the black square, the task guiding the choice of patterns. It's a good analogy. Yeah, or chaining them. It's a good analogy. I haven't thought of it.
And in your corpora, how you define the negative or the attitude statement? For example, if you see something like X killed somebody, is it a negative statement?
Well, luckily we weren't the ones who, let's see, we weren't the ones to make these decisions. I'm very happy to know that I wasn't, because it seemed to be really hard work. And we did notice, well, for instance, this set was less consistently coded. This was better coded. And we noticed that there was a definite difference between this set and this set as to what was good. And in the semival set there, for instance, a number of news items were about Iraq, because it was during one of the Iraq campaigns, one of the Gulf Wars. And there was one about, there were several like this, and those were all considered negative, but there was also one where I think one of Saddam's sons being killed, and I seem to remember that was a positive bit of news, right? Subjectivity. I mean, this is sentiment analysis, it is subjective, right? So You will never be able to do this objectively. But so, I'm happy I didn't have to do it, and it's messy. And it should be messy. I'm happy that it is messy, actually. But
Two different tasks, like
all right. And
attitude or the bad facts.
yeah, those are different tasks, and what it means to have. Let's see. There we go again. What for some of these, it's about holding an opinion. I believe that it's cold in Moscow. Is that a sentimental? You don't even know what I feel about cold. Maybe I like the cold. I don't, but maybe I like the cold, right? So.
I have a question. Please tell us how to translate your constructions on other languages, for example, Russian, Swedish.
I think that, well, okay, so one of the basic tenets, the theoretical starting points of constructional grammar is that nothing is universal, so that there is no standard passive, for instance. It's all learned the same way we learn a lexicon, just like there are words in Russian that have no equivalent in English, and even the ones that seem to have an equivalent are slightly different. Same thing with patterns, right? So there's a pattern, but on the other hand, I do believe that many patterns are so similar, so you can just, some of them will be, something animate eating something, right? Or someone thinking about something. Fine. That's universal, but not by virtue of it being a universal fact about language, but it being human language, right? People talk about eating. People talk about liking stuff. So those patterns should be translatable. Others that are more specific to a language, say, standard stock phrases from, sayings where English people might use a Shakespearean quote. You can't translate that. It's just a pattern they use when they're happy about something, right? So there's something else Russian people do in that situation, not translatable. I don't have a clock, so I don't know if I'm keeping you all from going back to work and seeing if the last compiler worked or not. But so what was the time? 10 to 10. And I think the official time for the seminar has ended a long while ago, so maybe we should release anyone who feels bound to their chair by politeness now. Thank you very much for your attention. This has been good fun.